First, we have to realize that this is a Doppler effect question, and then we have to choose which Doppler effect equation to use. Well, since the police car is the source and you're the listener, the police car is moving toward you. Therefore, in this case, we have a source moving toward the listener. So the equation for a source moving toward the listener is the first one that we learned, where the adjusted frequency equals the original frequency of the source times the ratio of the speed of sound over the speed of sound minus the speed of the source. And we can already tell from this one that we should expect a higher frequency than 1600 hertz since the source is moving toward the listener. As far as the information that we're given in the original problem is the frequency of the source, the original frequency there is 1600 hertz. The police car, so Vs, speed of the source, is 25 meters per second. And then we've got the temperature, 20 degrees Celsius. The reason they gave us the temperature is so that before we use the main Doppler effect equation, we can actually find the speed of sound, because we know that the speed of sound is going to be 331 plus 0.6 times the temperature, 20 degrees. So the speed of sound on this day must be 343 meters per second. Now I can take that speed and use that in my Doppler effect equation to find the adjusted frequency, where I'll plug in my original frequency of the source, 1600 hertz, times the speed of sound on top, so just V by itself is going to be 343 meters per second, over 343 minus 25. All right, so this ratio is about 1.079, meaning that my apparent frequency as I'm listening to this police siren is 1725 hertz, which we could round with sig figs to about 1700 hertz.